Hello everyone, I'm Professor Ricardo, and in this video we are going to answer this question: why we can write that the total time derivative of this quantity, which is the partial derivative of Ri with respect to Qj, is equal to del Qj of the total time derivative of Ri. This is a question in the context of classical mechanics, in particular of the Lagrangian formalism of classical mechanics. So first, let's understand the relation between Ri and Qj. Ri is a function of the coordinates, the generalized coordinates and time. And we do have n, capital N, transformation equations such as this one. So we are writing here Ri as a function of the generalized coordinates, Qn. And n, the lowercase n, is the number of degrees of freedom of this system. Okay, now the key information to solve this question is Ri is a function of the generalized coordinates and time. And this quantity here is also a function of the generalized coordinates and time. Why? Because the partial derivative of Ri with respect to Qj is going to be a function of the same variables, the coordinates and time. You will not have, for instance, generalized velocity here. The partial derivative of that function will be a function of the generalized coordinates and time as well. And then we can proceed with the total time derivative of this quantity, which is a function of the coordinates and time, as the partial derivative of that quantity with respect to each variable. First one, with respect to Q1, multiplied by Q1 dot, which is the total time derivative of Q1, plus the same for Q2 up to Qn, del Qn of this quantity, multiplied by Qn dot. And the last variable is time, so we will have the partial derivative of this quantity with respect to time, multiplied by the total time derivative of time, which is dt, and this is 1. Okay, now, since we are dealing with partial derivatives, we can interchange the differentiation with respect to Q1 and Qj. And then we can write the del Qj on the left and del Ri, del Q1, multiplied by Q1 dot. We will do the same for the second term, writing the partial derivative with respect to Qj on the left, up to this term here, which will be del Qj of del Ri, del Qn, multiplied by Qn dot, and the last term will result in del Ri, del T, because del Qj is written on the left of this term. And we can identify this term in green as the total time derivative of Ri. The total time derivative of Ri, since Ri is a function of the coordinates and time, will be del Ri del Q1, Q1 dot, plus, and so on, up to del Ri del T. And then we are going to write this term in green as the total time derivative of Ri. And the result is exactly what we would like to demonstrate.